Folks, welcome to the lesson. We're solving simultaneous equations by substitution. So let's crack on, get the job done. The method of substitution is particularly useful if your equations look like this, where one of the equations is written either y equals or x equals. And then the second one can be whatever it likes. Because when it's written y equals, we've got y in the top equation and y in the second equation. But if we look at the top equation, y equals 3x plus 2. So saying y is the same as 3x plus 2, which means in that second equation, we can take y and replace it with 3x plus 2. Because they're the same thing. And when we do that, our second equation now becomes not x plus y equals 6, but x plus 3x plus 2 equals 6, because we substituted y with 3x plus 2. And our equation now only has x in it, so we can solve it. And when we've found x, we can substitute back to find y. That's how we solve equations by substitution. So here's example 1. As ever, we label the equations 1 and 2. You'll know that if you've looked at the video on solving equations by elimination. We've got x in the first equation and we've got x in the second equation, and the first equation tells us that x equals 3y plus 9. So we're going to be substituting the x in the second equation with 3y plus 9, which means equation 2 will become not x plus 3y equals 15, but we're going to replace that x with 3y plus 9. So it's 3y plus 9 plus 3y equals 15. Simplify and then solve, and once we've found y, we substitute back into equation 1, and x equals 3 lots of 1 plus 9, so x equals 12. We think they're the right answers, but let's check. And we check this by substituting x equals 12 and y equals 1 into both equations. So when we substitute them into the first equation, we end up with 12 equals 3 lots of 1 plus 9. Is that right? Yes, it is. And when we substitute into the second equation, we end up with 12 plus 3 lots of 1 equals 15. Is that right? Yes, it is. So we know we're correct. Here in example 2, we've got x in the top equation and we've got an x in the second equation. In fact, we've got 2x in the second equation, but we're going to replace that x with 2y minus 3 because we're told from equation 1 that x equals 2y minus 3. So we're going to substitute that 2y minus 3 for x in equation 2. And when we do that, equation 2 now becomes not 2x, but 2 lots of 2y minus 3. And then plus y equals 19. This equation now only has y's in it. Therefore, we simplify and then solve, and we find that y equals 5. Once we've found the y value, substitute it back into equation 1, and we end up with x equals 2 lots of 5 subtract 3, so x equals 7. Again, we only think these are the answers, but let's check. And we check by substituting x equals 7 and y equals 5 into both equations. When we substitute into equation 1, 7 equals 2 lots of 5 subtract 3. Is that right? Yes, it is. And in equation 2, 2 lots of 7 plus 5 equals 19. Is that right? Yes, it is. We've got the right answer. Now, sometimes we need to rearrange one of the equations before substituting. So here we have our two equations, but we're going to take equation 1 and rearrange it first because we need it in the form either x equals or y equals. So I'm going to subtract 6 from both sides. Sorry, beg your pardon. I'm going to subtract y from both sides to leave us with x equals 6 minus y. And we'll call that equation 3. Now, equation 3's got x equals, and equation 2's got 3 lots of x. So I'm going to substitute the x from equation 3 because that equals 6 minus y. I'm going to substitute that for the x in equation 2. So equation 2 is no longer 3x, but 3 lots of 6 minus y. I've replaced the x in equation 3, which is 6 minus y. I substituted that into equation 2. We now have an equation which only has y's in it, which we can simplify and solve, and we've got our y value. We take our y value and substitute it into equation 3. That would be the easiest one to use. We could have used 1 and 2. It's just equation 3 is the easiest because it's in the form x equals. So x equals 6 subtract 8, and that gives us x equals negative 2. Once again, we need to check our answers. We substitute x equals negative 2 and y equals 8 into both equations. In equation 1, we will end up with negative 2 plus 8 equals 6. Is that right? Yes, it is. And in equation 2, we'll end up with 3 lots of negative 2 plus 2 lots of 8 equals 10. Well, 3 lots of negative 2 is negative 6. So negative 6 plus 16, does that equal 10? Yes, it does. We've got the right answer. Sometimes our rearrangement can be a little bit complicated. You might, in this example, actually not use substitution for this, but I'm just going to show you a more difficult example using substitution. The steps are the same. We label the equations 1 and 2. I'm going to take equation 1 and rearrange it, and I'm going to divide both sides by 2, so it gives me x equals 4 plus 3y all divided by 2. I'm now going to take that expression for x and substitute it into equation 2. So the x in equation 2 is going to be replaced with 4 plus 3y divided by 2. When I substitute in, equation 2 becomes 3 lots of, and then that x has been replaced with 4 plus 3y over 2. Subtract 2y equals 11. Multiply through by 2, and just be careful here, when I multiply through by 2, I've got to multiply both that fraction by 2, so the denominator disappears, but I've also got to multiply the 2y by 2, so it becomes 4y, and then the 11 is multiplied by 2. So the three things in this equation are all multiplied by 2. We've just got y in our equation, so we simplify and solve, and we end up with y equals 2. We then take that value and substitute it back And the easiest equation to use is equation 3. X equals 4 plus 3 lots of 2, all divided by 2. And that gives us 5 as our answer. Once again, we think we're right, but let's do the checking. We substitute x equals 5 and y equals 2 into the two equations. In equation number 1, we end up with 2 lots of 5 equals 4 plus 3 lots of 2. That gives us 10 equals 4 plus 6, which is correct. And in equation 2, 3 lots of 5 subtract 2 lots of 2 equals 11. 15 subtract 4 equals 11. That's correct. Let's put this all together then in a recap. First of all, label each equation 1 and 2. There we go. Substitute the letter from one equation into the other. So in equation 1, we've got x equals, and in the second equation, we've got an x. So we're going to take the x from equation 1, because it equals 3y plus 9, and substitute it into equation 2. So now equation 2 now becomes 3y plus 9 plus 3y equals 15. We can then simplify and solve, and we've got y equals 1. Don't forget to substitute that back in order to find our x value. So we'll substitute it into equation 1, and we end up with x equals 3 lots of 1 plus 9, and we get x equals 12. We now make sure we check our answers in both equations. In equation 1, we get 12 equals 3 lots of 1 plus 9. That's correct. And in equation 2, we end up with 12 plus 3 lots of 1 equals 15. And that's correct. And sometimes you may need to rearrange an equation before you substitute. So in this example here, we don't have either of the equations are not x equals or y equals. So we take equation 1 and we rearrange it into x equals. And it's x equals 6 minus y. And we use that x and we substitute it into equation 2. And then we continue solving. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.